Gross. Ew, gross. That's a big fraction right there. Nobody wants to derive that. That's just disgusting. All right, so dy dx would be y prime. So pretty much what we have to do is we have to take the derivative of this. How are you going to do that? Well, I can't cleanly make this not a fraction. I can't manipulate this and make it not a fraction. It's not going to be clean. It's going to be 3 sine x plus cosine x raised to the negative 1. Now, nobody wants to derive that either. Well, maybe you do. Maybe you would rather derive that. You could if you wanted to. You just have to use the chain rule. I'm not. I'm just going to go straight to this and derive that. And because it's a fraction, because we have a binomial on the denominator, I'm going to use the quotient rule. So I first take the derivative of the numerator, which is 0, and then I don't even have to write the denominator because it's just going to be 0. Then I go minus, and I take the derivative of the denominator, and I get, what is that? Derivative of sine is cosine x, and then the derivative of cosine is negative sine x. And then on the denominator, I have to square the denominator, so it's going to be sine x plus cosine x squared. Okay, so a little bit of simplification. All right, I'm going to have to distribute this negative. The 0 nobody cares about, so we have now instead a positive sine x and then a negative cosine x on the numerator. On the denominator, we have sine x plus cosine x squared. Okay. Oh, snap.
What happened to the 3?
What? There's a 3? Oh, yeah, that would be...
Well, in the first set.
Yeah, there should be a 3 right here, multiplying to it. Because you take the derivative of the denominator and then you multiply it by the top. So, yeah, so I got the 3 there. Let's see. I still distribute the negative. The 3 is still out in front. I don't care about the 3 right now. What I do care about is I'm looking at the answers. Do we have an answer down here? Oh, we do. Dang it. We don't have to simplify this? Man, I totally thought we would have to simplify this some more. No, I guess not.
Wait, how did you get to the second part, like after the 0 minus cosine x minus sine x minus 3?
Oh, how'd I go from here to here?
No, from the first part to the second part.
Oh, okay, you're saying like from here to here.
Yeah.
I use the quotient rule. So the quotient rule says I'm going to have to take the derivative of 3 and multiply it by the denominator. And then minus, I have to take the derivative of the denominator. Running out of space. Cosine x. And I have to multiply it by the numerator. Okay, the derivative of the denominator. Okay, and then I'm going to have to square the denominator, whatever the denominator might be. And so that's how I got this. And as Alexis lovingly pointed out, I forgot to put the 3 right there. Okay, because it's derivative of the denominator times the numerator. And that's how I got that. Then I took this negative right here, distribute it, just to try to clean things up a little bit. I left the 3 out in front. You could distribute it if you wanted to. Wait, this is negative cosine. That's not negative cosine. Oh, wow. None of these are the answer I need. So it looks like there might be a little bit more simplification to do. All right, let's do it. Let's do a little bit more simplification. Okay, so I'm going to distribute or multiply out the denominator to see if I can get something else. So I'm looking at the answers. I'm trying to use the answers to help me. I see a squared on that one. I see a squared on that one. I see a squared on that one. So my first reaction is, okay, can I somehow get rid of this to make it look like one of these? And it doesn't look like there's a way for me to get rid of that. I can't cancel the factors out because of the minus sign. The signs aren't the same. And so my guess is this guy, and this guy are not going to be the right answer. It's going to be one of these two. All right, so let's see if we can change up this this denominator, or let's see if things get canceled out. All right, so I'm going to multiply out the denominator. So we have sine x plus cosine x times sine x plus cosine x. Notice that it's not as simple as me just distributing the 2. That's totally wrong. That's completely wrong. The power says that we go this times this. So now I have to do a lot of rainbows here. So sine x times sine x is going to be sine squared x. Sine x times cosine x is going to be sine cosine, and then cosine times sine is going to be sine cosine. So I have two sine x cosine x's. Did a little shortcut there. Now the last one is going to be cosine times cosine, which is cosine squared x. And this is kind of weird. You can use a trigonometric identity, and I'm showing you by grouping together the squares right here. So it would be cosine squared x, sine squared x plus cosine squared x plus 2 sine x cosine x. And this right here equals 1. That's what that equals. That's a Pythagorean identity. So let's rewrite what we got. We got 3 sine x cosine x. Then we have 1 plus 2 sine x cosine x. Now we got this. And the numerator. Sweet. So our answer is definitely E.